things I learned is, despite the strong representation of mathematicians, they don't seem to be able to read the numbers on the time. I'm now starting at 9:45, which is 15 minutes late. I guess they can work that out. I would just like to know, semi-seriously, am I supposed to finish at, what was it?
Half an hour.
I've got half an hour. Oh, okay, that's fine. Thank you very much. Yeah. So, good morning, everybody. I'm sorry we are behind time, and I guess we will be for the foreseeable future. The other thing to say is, you know, it's very tempting when thinking of a dramatic title for a talk like this to sort of conjure up the sort of doom and gloom. And I really was tempted, but decided I'd avoid that. I mean, I think it is unhelpful. There is a lot of problems, and I don't need to put that into the title. The other thing I want to say, just as a preliminary, is I do believe there are some friends in the audience, and you know, if you or your organization feel I'm being unfair in the remarks that I might make, please accept they are generalizations and they're not meant to be hurtful. Okay, so the thrust of this, of course, is about the conundrum of quality and quantity in STEM education. And that's common cause across all the MST subjects, and it affects scientists, engineers, teachers, policy planners, and in fact the nation. It's a quality and quantity issue everywhere that you turn, and it's no different in our particular little sphere of interest. I'm going to talk about things firstly in a rather general way, and I'm going to start off by, shall we say, giving my view on the current state of affairs, and then move on to, shall we say, the why and how, and of course finally conclude with some remarks that may be useful for further discussion even later today or on some future occasion. So firstly, my view on the current state. Oops, this is always the heavy-handed. Yeah, okay. Sorry, I'll get used to it in a while. Let us not overlook there is quality in the system. And one way that we very easily and casually can see it is through these fairly public recognition ceremonies and devices that we have grown familiar with. And in fact, of course, the NSTF is mentioned here because they are the conveners of this event, and they have the Science Oscars, as they have recently labeled them, a wonderful way of reaching and giving respect to individuals who have all kinds of contributions to make to MST and to STEM. And then we have this publication, which I want to mention, which I was unaware of. What a great idea. And it's a lovely book, which I received via NSTF, published by DST, that is a mine of ideas for stimulating one's own thoughts and also that of students and learners around the country at various levels of education. It's full of inventions that have originated in South Africa and really, what a pleasure. And then finally, of course, the professional societies who stand behind this particular discussion forum, they almost all, in fact, all, I'm sure, have their recognition mechanisms for recognition, that is, of quality contributions to the field. So we have quality outputs from our system, whatever it is we say is problematic about it, and that is something we mustn't entirely forget. So let us move on to the key issues of quality and quantity in our particular sphere. I will give emphasis to things from the science domain because that is mine and it's one that I understand more fully. And I'm overlooking the mathematics, but I know that in fact everything that is said here about science has its parallels in mathematics. So please also understand that shall we say, lack of balance in my particular examples. And firstly, we have the school system as a whole. It is a tragic kind of figure to see this 30% only reaching to grade 12. That is where you might say the problem starts, in a manner of speaking. And then we go to the matriculation scenario. And in physical science, we see these very low participation rates and very low pass rates, even with a passing mark of 40%. And then finally, in the university system, just a quote from Jonathan Jensen, and I'm sure it is correct approximately. Only 30% of all students across all universities and all subjects, only 30% complete their first degree in the prescribed time. And out of that, of course, you can deduce, perhaps, that the matric exam pass rate is not a sign that the level of that matric exam is too high. It's not too high, as a matter of fact, because according to my interpretation, the university system is failing them at a devastating rate. So all through the system, from the beginning, and I'm not counting, of course, pre-school years, which one may also count, right through the system, there is a disappointing throughput of people, individuals, children, and students. And the short of it is, we can't go on like that. So, okay, that is enough doom and gloom, you might say. Let's try. Oh, gosh. I'm trying to catch up time, you see. There we go, okay. Of course, there's plenty of people in this room, including from Ukonda Institute, plenty of people within the Department of Basic Education, within NGOs, within universities, blah, 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 blah. Everybody is trying to reduce wastage in the MST education system. And probably everybody in this room is familiar with this catalogue of contributions that are being made. And there's going to be a talk further about this kind of activity in relation to in-service education and development of teachers. And they focus these different activities on improving the matric pass rate. That is one particular focus. And then there are others, you might say, are really more focused on improving the participation rate. And there you have these science fairs, science centers, and what have you. There's an enormous, one uses the word industry here, in trying to reduce wastage in the system of the type we've just described, and which of course is basically familiar. So let us move on from that sort of overview. You see, I don't want to mull over those particular things too much. There's no particular reason. And I want to move on to the why and the how. Oh, yeah, okay. And so the why and the how. Well, the first thing that is picked up here is the low participation rate in physical sciences. Why is this so? And it turns out that we need to pay attention, according to me, to the teachers. There is no doubt that learners do understand why it's important that they should try to study physical sciences. They do see and hear that there are these opportunities, there are these ambitions, there is employment that would flow if they did study physical sciences and succeeded. But they also know that the chances of them succeeding are poor. They also know it's a difficult subject. They also know that the pass rate is poor. They also hear stories in most schools that say that the teacher in the physical sciences subject isn't really up to it. That is the reality. They don't inspire the learners in physical science, those teachers, because they can't. For a long time, even when you go back as long as I go back, there has been this acceptance almost that we're short of physical sciences teachers, that life science teachers should be asked to take on the job, and they do. And no doubt, they do their very best, and we must acknowledge that. But they haven't been prepared to teach physical science, and they don't understand, and they don't know, and they cannot easily inspire. These are realities across the majority of schools. And so we're stuck with the realization that we have here a pathway presented to the learners through physical sciences that says, go this route because there's opportunity here. And yet, all the evidence that the learner has tends to say, don't try. And so they move to life sciences, or maybe they move away completely from science, and maybe they are right. And we do finish up, so I'm arguing, with a low participation rate. It's only those who are persuaded to give it a try, however daunting and uninspiring it seems. And so we have a situation where I see an analogy with mathematics and mathematical literacy, that students are, or learners are, warned off from doing mathematics where the pass rate is very poor. And they're told, never mind that that is what engineering requires or science requires at tertiary level. Go for maths literacy because mathematics is hard. In the case of physical science, they get pushed not to maths literacy or science literacy. There is no such thing. Okay, so I'm suggesting the low participation rate in physical sciences is in many ways a product of what the teachers have to offer.